afternoon and welcome to our final session for day 3 of the IMarEST annual conference. I'd like to take this opportunity to thank our sponsors for this session, SGS. If you would like to ask a question, you can do so through Slido using the event code Marine Plastics. I'll now hand over to our host for this session, Dr. Sajid Hussain.
Thank you. Hello, everyone. We welcome you from the IMarEST annual conference. Today's third and last session. It is going to be a very interesting plastic talk. And with the title, Marine Plastic Debris Tackling a Global Waste by Ms. Stephanie Lavelle. Stephanie is a project director for Sea Sanctuaries Trust and a researcher at the University of Southampton, currently investigating the potential impacts of plastic pollution on marine ecosystems. As a member of IMarEST for nearly 5 years, she has helped initiate efforts towards the newly established Plastic Special Interest Group and the IMO Plastic Working and Correspondence Groups. Her previous experience includes working for Chelsea Technologies with regards to compliance monitoring for the ballast water and sulphur cap regulations, as well as for international conservation organizations in Indonesia and in Madagascar. Let's welcome Stephanie.
Thank you very much, Sajid, for the introduction, and thank you very much to IMarEST for hosting this brilliant conference online and inviting me to speak about marine plastic debris. So I'm just going to share my screen. Is that working okay?
Yes.
That's working okay. And so, yeah, thank you very much for the introduction. I'm going to give a brief introduction to this huge topic and how we've been using technology to monitor plastic over the last few decades. And then we'll take a look at our scientific understanding of the potential impacts and how we're expecting the industry to grow. And then we'll discuss how policy and technology can help guide us out of these environmental disasters and how ultimately we are trying to transition to a circular economy. The newly established IMO and IMarEST plastic groups are also working more closely with the maritime industry to reduce their impact, which I'll also introduce in more detail at the end. So it's a widely accepted fact that around 80% of marine plastic debris comes from land-based sources, and around 75% of this comes from unmanaged household waste. As for many countries, it's simply not financially feasible to invest in waste infrastructure and recycling. The other 25% leaks from within the waste system itself. And as the majority of our waste is sent to landfill, this is a huge source of leakage into the ocean. As you see here, this is a waste atlas by Leeds University, and it shows the 50 largest dump sites in the world, which, as you can see, are mainly coastal or near rivers, and so pose risk of leaching. Even in the UK, we are bursting at the seams, and sites all over the world are facing issues of coastal and soil erosion as a result of climate change. One study in the UK found that there's around 20,000 historic landfill sites that didn't have regulations in place at the time that they were being used. And it's been estimated that at least 5,000 of these are lying at risk of flooding and coastal erosion. There are still gross uncertainties when it comes to marine plastic waste budgets because the ocean is forever moving them. But there is a growing focus to help develop databases, maps and apps, which are also being helped with advances in remote sensing and more refined field sampling to help us better understand the global flow of waste. As essentially we need to be able to measure it in order to manage it. This platform, Litterbase, was compiled by AWI in Germany to share the data from over 1,000 publications, highlighting here macroplastic densities per kilometre squared. And studies such as this one from 2014 even mapped out abundances of the smaller plastic particles in quite impressive detail. And such collective and continuous data is not only important to help us understand the sources and distributions of plastic, but it can also help us develop traffic light systems to reduce leakage and identify best practices. To give a bit of perspective on beach cleans, I thought it would be a good example to show you the world's biggest beach clean. And this was started by one man who ended up with over 1,000 volunteers, and they worked tirelessly for 2 years. And they did an amazing job and removed around 5,000 tons of plastic from this beach. But unfortunately, it's also quite a widely accepted fact that at least easily 1 million tons of plastic enters the ocean every month. So quite simply, we're not going to be able to beach clean our way out of this. Beach cleans have provided a lot of data for us though. And as you can see from this example here, we can see cigarette butts are really a millions per minute habit, with trillions entering the ocean every year. Various items of often branded consumer packaging. From this study, we can see that packaging, textiles and other consumer products are by far the biggest contributing industries. Around 80% of marine plastic debris, as I said, comes from land-based sources, but ocean sources, such as from shipping, fishing and other ocean platforms, are around 20%, but this has been found to be higher in certain areas, particularly in areas with high fishing, high illegal fishing activity, as well as at subsea and surface convergence zones. And fishing gear is by no means a new problem for marine life, but the accumulation is becoming more detrimental to already severely pressured species. The range of estimations is pretty huge. This one study from the UN in 2009 estimated over 600,000 tons of abandoned, lost and discarded fishing gear entering the ocean every year, amounting to about 10% of marine plastic debris in total by weight. However, there are some studies suggesting that it could be up to 70%. Collection of nets is very much limited to volunteers, and recycling disposal still remains very challenging. And a more recent study published in Nature used a combination of sampling and remote sensing, predicting at least 79,000 tons of floating plastic within the Pacific garbage patch, a figure which is about 14 to 16 times higher than previously reported. And nearly half of this is thought to be made up of fishing nets. Asia and Africa have been assessed as the most critical hotspots for marine plastic debris, and a well-known study by Jenna Jambeck and others evaluated 5 countries in Asia to be responsible for over 50% of the plastic leaching into the ocean, namely China, Indonesia, the Philippines, Thailand, and Cambodia. But rivers are also a hugely under-considered input, with another recent paper estimating that the majority of waste is entering the ocean via 5 rivers, 4 of which are in Asia and 1 in Africa. But even in Europe's second largest river, the Danube, microplastics have been found to outnumber fish larvae. And this photo from a river in Jakarta shows just how bad things are getting. And although countries in Asia have been identified as some of the biggest contributors, the responsibility is far more complex. For example, one big issue is tied to international companies selling single-use sachets of products, such as shampoos, which are unrecyclable, but are so popular because they can't afford to buy anymore. So there are very difficult socioeconomic constraints, including a severe lack of waste infrastructure and regulation, which has also given rise to a huge import of waste. And countries that definitely have the highest plastic use per person are often praised for their high recycling rates, but the reality is they only tend to recycle high quality plastics in country and export the majority across the world on container ships. The EU are the biggest exporter of plastic waste, with Japan and the USA being the two single biggest exporters. This helps these countries technically meet their recycling budgets and save on landfill space, which is also globally limited. But the reality is we're transferring our problems to low and middle income countries that don't tend to impose regulations. Some of this waste is viewed as valuable for recycling, but the majority is ending up in illegal landfill or being incinerated. China, who have reportedly imported over half of the world's plastic waste, banned imports in 2017, and exports are thought to have fallen by up to half. So this data is from 2018. And this is leaving hundreds of millions of tons of plastic waste with nowhere to go. There are some countries such as Malaysia and Indonesia that have become popular sites to take up the slack. However, they've also been sending waste back for being contaminated or incorrectly labeled as recyclable. In fact, a huge shipment has just completed a round the world trip to be incinerated not very far from where I live. One of the biggest questions around plastic is how harmful is it to human and marine organism health? And although surrounded by it in our daily lives, there's been calls to label plastic as hazardous. And according to UN frameworks, over 50% are hazardous based on their constituent monomers, additives, and contaminants that they accumulate. There is growing evidence that plastic pollution is also hazardous to groundwater and soil processes, but it's certainly the impacts on the marine environment that have become a big scientific and public concern. However, the potential impacts of plastic ingestion leading to chemical transfer remains a big area of debate. Some studies are suggesting that entanglement actually poses bigger threats than chemical contamination. However, nanoplastics have become of a more recent concern, and they've been found to cross the blood-brain barrier and the gastrointestinal barrier. But similar to microplastics, they remain very challenging to study. However, we do know that they are absolutely everywhere in the Arctic ice and the air that we breathe, in our food and our water. But yeah, this is still a relatively new area of research. The plastosphere is the term being used for the biomes that quickly get established as soon as marine plastic enters the marine environment. It can be within a matter of days. And these have been speculated as a potential vector for pathogens, not only for people, but for coral species, for example, and also as a potential vector for invasive colonizers and harmful algal species. However, these sorts of ecosystem level impacts have only yet been speculated. I think people are probably becoming quite desensitized to these images as they are now so commonly seen. And although we can see impacts across countless individuals and most species, we do have to ask, is plastic pollution a planetary boundary threat? And it certainly covers two aspects in that it is global and it is persistent. However, we still understand very little on the impacts on whole populations, its transfer in the food web, and impact on ecosystems. And this is a big part of my current research, is to understand such critical thresholds that we might reach, whereby we would see significant changes in food web structure and function. And we're doing this by assessing the impacts on carbon sequestrating phytoplankton, as well as higher trophic level consumers under various levels of surface plastic. And we would hope not to reach such dense levels, but in some areas this is potentially already happening. The biggest concern is the growth of production. Since 1950, we've produced over 8 billion tons, and over half of this has been single use, and less than 10% has been sent for recycling. We're currently producing over 300 million tons, which is about the equivalent to the human population by weight. And this is expected to double or even triple in the next decade, reaching 1,500 million tons by 2050. This data from the Plastics Economy Group also identifies that the growth consumption is largely going to be in Asia, the Middle East, and Africa, and predominantly in the packaging industries. While we as individuals worry about our plastic bags, reusing bags and reusable bottles, the petrochemical industries, including some of the largest companies in the world, continue to invest billions of dollars in new plants, partly in response to the expected decrease in demand for fuel. This picture here is from a nearly 100-mile long stretch down the Mississippi, commonly referred to as Cancer Alley by the media. But the fracking boom in America has made them an even bigger epicenter for plastic growth. And they have at least 11 new ethylene plants planned with a growth capacity of 30% projected by 2022. But this is thought to be an underestimation of growth according to the Center for Environmental Law, so International Environmental Law Analysis, who estimate that associated plastic emissions are going to at least triple by 2050. And according to the American Chemistry Council, investments grew by 25% in 1 year. And the International Energy Agency also expects petrochemicals to drive half of the demand for oil leading up to 2050. So we can see plastic and climate change are really all part of the same problem. The annual emissions associated with plastic production already exceeds the output of most countries. And if it's allowed to continue to grow like this, by 2050, it will exceed the equivalent of 600 coal stations. According to Judith Enck, the founder of Beyond Plastics and former regional director of the US Environmental Protection Agency, this is why 2020 is so crucial. There are a lot of these facilities currently in the permitting process, and we're pretty close to it all being too late. If even a quarter of these ethane cracking facilities are built, it's locking us into a plastic future that's going to be very hard to recover from. Not only do we have all of these environmental costs to worry about, but the World Bank has estimated billions of dollars in damages and costs to tourism, fishing and shipping industries. And a more recent study estimated that $3,000 to $33,000 in economic costs per ton of marine plastic per year, which overall incurs a 1% to 5% decline in benefits, amounting to $2.5 trillion a year. So unquestionably, just like climate change, prevention is going to be cheaper and have far less consequences than damage repair. So let's now take a look at what we've been doing to prevent these problems. So legal strategies and workshops to address plastic have been in place for decades. At an international level, plastic is addressed by MARPOL for ships, but as with many other regulations, compliance and enforcement remain significant problems. Furthermore, 99% of small fishing boats are exempt from stringent waste handling regulations. The first workshops highlighting marine plastic debris as an issue were in the early 80s, with NOAA recently hosting the 6th Marine Debris Conference to promote response and education with guidance from the Honolulu framework that was developed in 2012. It was at the turn of the century when our consumption passed 1 million plastic bags and 1 million plastic bottles a minute, when Bangladesh became the first country to impose a ban. And now over 70 countries impose bag regulations, with Africa standing out as having over 25 countries impose total bans. The year that really surcharged focus on marine plastic debris was 2017, due to the ban on imports from China, coupled with Blue Planet 2, which definitely had a big impact on people. As a result, there have been many new partnerships and working groups established under the responsibilities of the Basel Convention, the Stockholm Convention within the United Nations Environment Programme, the FAO and the IMO, as well as many more local and regional groups. These efforts have helped push through some new proposals, including the EU to start prohibiting some single-use items such as cutlery, plates and straws from next year. But we have to ask, are these efforts enough when we consider the extent of our plastic addiction? Technology is certainly helping us more than ever before. It's helping us remove and sort through plastic. As you can see on the top left here, we have an AI sorting machine that's identifying plastic bottles at a quicker rate than people can. And various river removal technologies that all come with their own costs and benefits. We can see in the top right one of these bottle collection deposit schemes that are gaining traction in a lot of countries. And on the bottom left, this is a net tag. This one was developed by Newcastle University for around $300 per tag, and it's to help locate nets acoustically. And I read an article yesterday, actually, that there's a non-profit organization, the Ocean Voyage Institute, working out of Hawaii, and they've worked with volunteers on yachts who've gone out and tagged large floating plastic accumulations that they found in the Pacific. And I think it was last week, the group broke the world record by then sending out one vessel to collect all of the tagged waste, and they managed to remove 100 tons in just 48 hours, which is one of I think it's the best effort to date. This has been one of the more well-known projects, the Ocean Cleanup, another non-profit group that are hoping to deploy a 100-kilometer long floating barrier in the Pacific, hoping to remove over half of the surface floating plastic. However, critics claim that the plastic is too dilute for this mechanism to scoop up, and they worry that the barrier might disturb fish and plankton. However, the NGO has over 1,000 hours of monitoring and have found no substantial interference with ocean ecosystems. But they have also developed this solar-powered river cleanup system as well. But the bigger challenge is, what do we do with all this collected waste? When it's exposed to the marine environment, it's growing these biofilms within a matter of days, making recycling particularly difficult. So we really need to be collecting waste closer to the source and preventing it entering oceans at all. Recycling is certainly a big initiative. And while virtually all plastics can be recycled, many aren't, because the resulting product is of lower quality, and many items tend to only be recycled once. Despite decades of initiatives, we've recycled less than 10% of what's been produced. And so we need to increase our recycling by tenfold to keep up with just today's demand. In the UK, there's 28 different recycling labels that can appear on packaging, and in some areas in Japan, there's over 45 separate categories that locals wash, sort, and take to the local recycling centre. And this collection, washing, and processing are all energy intensive and expensive, making it difficult to collect enough to be economically viable. Recycling also requires at least a 10 to 20% injection of virgin plastic as chemicals accumulate that are added during manufacturing. And so therefore it's still keeping us dependent on fossil fuels. The new plastics economy also state, without fundamental redesign, over 50% of packaging will never be recyclable. And in comparison to the packaging boom, the growth of the industry is relatively slow. But some researchers predict a 6% growth in recycling, pushing its value from just under 40 billion to over 60 billion over the next decade. There's a growing number of small-scale initiatives, as it is possible to recycle anything. Even old fishing nets, when cleaned, can be made into bags or sports nets. Some companies are providing equipment back into aquaculture and fisheries, or even making items like surfboards and sunglasses, and a skateboard here by a company called Burio. And they're doing that by transforming marine plastic waste back into its pellet form. However, there's only a handful of companies doing this globally, as the processes remain very expensive, and therefore the items also remain very expensive for people to buy. The EU, one of their big initiatives is to impose a tax on recycled content. However, critics say this is still only going to cover about 5% of plastic demand. Nearly 200 companies in the UK have signed up to the Plastics Pact, but again, critics say these are very ambitious targets, as we have very little focus on reusing, and compostable plastic generally ends up in landfill because we don't have a waste stream for it. And so we're still very limited regarding being able to use compostable and bioplastics, and our recycling rates, collections and technologies are still also very limited. Furthermore, recycled content reduces the quality and cannot be recycled with high quality PET plastic bottles. But increased recycled content is becoming mandatory, and the EU have fast-tracked nearly all of the recycling processes that have been applied for. And although this will help create jobs and increase recycling, there is concern from scientists because these processes have not been independently tested by labs. And so they are concerned about things like legacy chemicals and perhaps air quality. But on a positive note, companies have been forced to think about the recyclability of their packaging as early as the design stage, and packaging is, well, they are committed to increasing the recycled content. Chemical recycling is also becoming a new hot topic. Again, critics say that the technology is still very young and limited, and in order to make new plastic products. And so the majority of these plants are actually looking to make oil or gas and are being put under this term waste to energy. And this plant here, after around 10 years in the making, Copenhagen's imaginatively designed waste to energy plant opened last year. It cost over $500 million and is equipped with a ski slope and a climbing wall, aiming to help Copenhagen become carbon neutral by 2025. They now claim to recycle 45% of their waste, with less than 2% going to landfill, which is down from over 40% in 40 years. And the rest is going to this facility and is used to generate heat for the city's heating network. It sounds sensible as plastic is more energy dense than coal, but it locks cities into providing a steady stream of waste, which is often imported from far away. It also contradicts the circular economy model, which aims to keep resources in use as long as possible. And studies have also shown recycling saves more energy by reducing the need to extract fossil fuels. We could theoretically reduce reliance on fossil fuels by up to 80 to 90% with using a 10 to 20% of injection of virgin plastic. But waste to energy is only securing reliance on a constant waste stream, not a reduced one. Is plastic a renewable energy? Well, the EU considers burning carbon-based waste renewable and eligible for subsidies, but it's not renewable in the sense that wood, paper, or food or cotton is, because we get them from fossil fuels, and every step of the process is causing pollution. The main argument really is waste to energy more desirable than landfill? Waste to energy is obviously more CO2 intensive, but landfill just produce a more potent greenhouse gas, methane. And there's also the element of space that we are seriously running out of, and obviously leaching into the ocean as well. And one of the main concerns in the growth of waste to energy in Asia, so for example, China already have hundreds of waste to energy plants with over 300 already in the pipeline. And many other countries in Asia are investing in this. Experts are worried that scrubbers for cleaning the air aren't going to be used. With so much waste mounting up, incineration becomes the only available alternative for many. And the bans in Asia have also led to significant drops in prices for plastic waste. So for many businesses, this has meant it's no longer worth separating materials, and so much more is going to local incinerators. People generally protest heavily against incineration and waste-to-energy plants near where they live, because of the air quality, the CO2, and again, another big concern in low and middle income countries is open incineration, where recycling and landfill is limited. So alternative packaging, this is a very new market and a very quickly growing one. There's many different types of bio-based and fossil fuel-based bioplastics. Some are biodegradable, some aren't. Many bioplastics need high temperatures to break down, and as I think I mentioned earlier, they also contaminate PET and recycling, so are often ending up in landfill. And in landfill, they are starved of oxygen and risk emitting methane. So these solutions only really tend to work if the packaging company also controls the recycling stream. Currently, bioplastics are around 0.2% of the market share, and although expected to grow, only a few countries have developed any sort of approval rating for biodegradable and compostable items. Bioplastics at the moment are typically made from around 15 to 20% organic waste or plant material, which is much more sustainable to produce. It decreases our dependence on plastic, and it doesn't contain as many chemicals. Coca-Cola, for example, have developed a plant-based plastic in order to meet the new required recycled content laws. So they are now growing, I believe it's sugarcane, to have a plant part to their bottles. However, they're specifically growing this sugarcane and cutting down Brazilian rainforest in order to do this. This is similar to challenges with biofuels. Bioplastics that are going to use materials specifically grown for producing the plastic will require land, and it will result in a higher amount of pollutants from fertilizers and pesticides. And although they will produce significantly fewer greenhouse gases over the lifetime, it's much more preferable to use waste material. And there are projects working on developing 100% bio-based PET, recyclable plastic. Yeah, there's many small initiatives coming out with some really great ideas, but as I said, it's still a very, very small percent of the market share. A study in 2017 determined that if the US would switch from traditional plastic to corn-based plastic, it would cut their emissions by their greenhouse gas emissions by 25%, and substantially more if production relied on renewable energy. And yeah, we've got a lot of examples here from some small countries all over the world using different mushroom waste to plant-based waste, food waste, algae waste. Even I've seen a company using shrimp shell waste to produce a bioplastic. But again, as I said, if it's not completely biodegradable, then the producers really need to be taking responsibility for the waste stream. Zero to landfill is becoming a goal of many towns and cities across the world, where they're trying to encourage the most out of local resource by encouraging us to use less, reuse what we can, and treat our waste like a resource. It is estimated that $80 to $120 billion in material value are lost each year. And case studies have shown that, in contrast with burying or burning our waste, preventing, reusing, and recycling creates jobs and saves money while protecting the environment and human health. And these are also many of the same solutions for climate change: buying local, reducing what we use, reducing the transport costs associated with what we're buying. And so the milkman principle is also becoming popular, and there's been a company called Loop that's gaining a great success by offering food delivery with big brands items in reusable packaging. But ultimately, we do need to be buying local and seasonal where possible to reduce our footprints. So how are we getting on? What are we trying to do? We are trying to juggle economic and environmental feasibility while trying to turn this linear model that we currently have, exhausting marine resources and polluting the environment, into a circular model. However, the circular model has received criticism for largely focusing on recycling and recycling content, as realistically there's a footprint along every step of the way, and we're ultimately producing too much to recycle our way out. The circular model not only has very ambitious recycling targets, but there isn't any real plan of how to reduce our consumption or dependency on fossil fuels or harmful chemicals. There's no profit in reusable, so industry majors want to focus on recycling so that they continue to sell large volumes and invest in waste energy. But unfortunately, there's just currently not enough effort in changing the design and production processes on consumer items. In order to deter costly legislation, producers and big industry for decades have created and implemented solutions that appeal to the environmentalist concerns, yet in a way that defines individual consumers, not producers, as the source of environmental degradation. In the last 6 months, the media's attention on plastic and climate change has practically disappeared as the world has had to face the consequences of COVID-19. So essentially, everything that I've said is probably a gross underestimation because plastic packaging is expected to grow even more. We now have a whole new dependence on single-use plastics in aid of tackling the transfer of this infectious disease by our use of masks, gloves, bottles of hand sanitizer, sterile wipes, and also the increase in packaging with the increase in home deliveries. And we're already finding this stuff littering our environment everywhere. And even before this, in 2019, prices of plastic fell between 30 and 50% for general commodity plastics and engineering plastics. And so if businesses have no incentive to use the more expensive recycled material, it could seriously damage the recycling industry and our ambitions to eliminate plastic waste. I mean, the UK already has an ambitious target to eliminate all plastic waste by 2043. But as long as companies are not held accountable for the full life cycle, recycling rates will simply remain linked to the price of oil, making it cheaper to use virgin plastic. I thought I'd also share these images from an article in The Guardian recently that shows how the pandemic has turned us into a plastic planet more than ever. So solutions, as our previous speaker very rightly said, you know, we're not short of solutions, we're short of ambition and drive to implement them. We need more regulations and incentives for sustainable alternatives, and we need accountability from stakeholders and governments. Some experts say we will find anything to wrap in plastic unless we target production. And while consumer behaviour is a contributing factor, at present, the fundamental economics of most plastic recycling industries simply do not work. The plastic majors are expecting up to a 40% increase in production over the next decade, and the trade in plastic across borders remains largely unregulated. As of now, there is no mechanism or regulatory body to ensure transparency and accountability of stakeholders in the plastic value chain. This is a global problem that needs a global regulatory response that also increases accountability from governments as well as producers through elements such as establishing national reduction targets with a framework of actually how to achieve that, and also establishing monitoring requirements and harmonised standards and definitions. Critics dismiss many goals as an unrealistic greenwash, but 186 countries have passed measures to track and control the export of plastic waste to developing countries, and more than 350 companies have signed a commitment to eliminate the use of single-use plastics by 2025. Ultimately, we need to revise waste policies to follow principles of a circular economy and ensuring no incineration where possible and incentivizing reduce, reuse and recycle in that order. The maritime industry has a responsibility to protect our marine environment, and it is also one of the best equipped mechanisms to identify where capacity can be further developed. The IMO has pledged to further address some of the problems posed by plastics with the adoption of their action plan, which aims to enhance existing regulations and introduce new supporting measures to reduce marine plastic litter from ships. Recognising that more needs to be done, the environmental and health problems posed by marine plastic litter are also going to be addressed with working with the IMO, and the IMO will continue to work with UN partners, including the FAO, GSAMP, get my acronyms correct here, I've got some notes on what they all are, the global group of experts on the scientific aspects of marine environmental protection, also the UN Environment Managed Global Partnerships on Marine Litter, and the UN Open-Ended Informal Consultative Process on Oceans and the Law of the Sea, the ICP, as well as other regional, more local and regional groups. The action plan from the IMO supports the commitment to meeting the targets set in the UN's Sustainable Development Goals for protection of the oceans. And MARPOL already does oblige port reception facilities to ensure adequate waste facilities, but the majority don't have this, and there's no universal system on fees or things like that. Even less than half of the ports in Norway have adequate port reception facilities. Ideally, moving forward, we should be having more organized ports where we see value in waste material and understanding how we will then use that material for innovation in ports. Overall, this should provide a good opportunity for ports to enhance their facilities and take waste actively collected and produced by vessels, so we can develop more organized ports and yeah, really see this value in the waste that we're producing. Crucially, improving collection and end-of-life processes for fishing gear, as well as other waste. And this can also be achieved through landfill tax, take-back schemes, penalties, and recycle-friendly design. I've got some examples specifically to nets here. I mean, large commercial nets can be worth easily a $250,000. So there's a huge market for repairing these nets. And as I mentioned before, some companies are recycling nets into sunglasses, bicycle baskets, clothing. But a major issue is that currently there's only two major recyclers of nets in Europe. One is a company called Plastics in Denmark and another called Aquafil in Italy. Some companies like Adidas, these trainers here, have invested in ocean plastic trainers, although we have to be aware that it's very unclear how much plastic they're using. What's the quantity of plastic being used for you to be able to market it as you helping with marine plastic pollution? About 0.1% marine plastic debris that's been put into those shoes, or 0.001%. But yeah, there is also a big market for flooring, carpets, and car parts. And we'll see more growing business cases like this emerge as producer responsibility starts to grow and as we start to move towards closing the plastic loop. Even this on the top right, I just have an example of even how COVID has led to this Chilean company called Green Spot having had great success in developing the first sanitizing foot bath mat that's made from 100% recycled plastic, mainly sourced from Chilean salmon farming buoys, floats, and disused containers, which I thought was quite interesting. So yeah, there are now various laws that provide a set of opportunities for us to address plastic, but there needs to be an expanded effort from administrators and manufacturers to highlight that it's a hazard covered by pollution laws. And the new IMarEST Plastic Special Interest Group is set to launch next month, where we're looking to collate a range of experts and stakeholders from across the industry to help feed into the efforts at the IMO and help further develop education and other initiatives within the maritime and marine industry. So if anybody is interested, then please get in touch with myself or Katrina at IMarEST. And yeah, we will hopefully be working towards meeting some of these UN Sustainable Development Goals. And yeah, thank you very much for listening. I look forward to any questions.
Hello. Stephanie, you did well. I am pretty confident that listeners are loaded with their interesting information. And I believe that there are 11 questions now from the audience. And we have quite some time in our hands, so therefore I'm going through the questions. Rolly says,
I'm sorry, Suji, could you hold your microphone a little bit closer?
okay, yeah.
Thank you.
Rolly says, should the London Dumping Convention be modified to ban totally the leaving of plastic material arising from maritime activities such as fishing nets?
Could you repeat that, please? Should the London
Dumping Convention be modified to ban totally the leaving of plastic material arising from maritime activities such as fishing nets?
Well, the irony is a lot of this dumping is already covered in many pollution laws. It is illegal to dump waste at sea, and that covers fishing net, which is obviously predominantly plastic these days. There are efforts to try and make labeling of fishing gear mandatory, which I think is going to be one of the bigger efforts. It's already been suggested in the Cape Town Agreement, which we're hoping to get ratified as soon as possible. And yeah, mandatory labeling of fishing gear to help reduce these problems is hopefully going to be on the table to be discussed as becoming mandatory.
Thank you. Rolly's second question, what is your view of the marine science community use of deployable sensors with high plastic content such as Argo floats that are not subsequently recovered?
Good question. I think there has to be a balance. I think, we need these floats to get a really important scientific information, particularly pertaining to climate change. So I think, within the scientific community, there could definitely be a better level of responsibility. Maybe we could put acoustic tags on these systems and try and recover them. But to an extent, it is important that we're monitoring the ocean for water temperature changes in phytoplankton, etc., which is really valuable information we're getting from these floats. And I think science, sometimes there is an element of sacrifice. Like in some of the research that, I've had to do, research vessels go out and capture a fish and sharks for scientific investigation. And so, to an extent, we shouldn't be doing that because some of these species are already endangered. But on the other hand, we need to know the information from doing these studies.
Well, thank you. Next question from Zayan Pillai. Mankind has lived without plastics for thousands of years. Why not ban all plastics for the damage plastics do to the environment?
I really wish we could. Unfortunately, plastics are just really useful. They're very lightweight. So when you consider maybe, why don't we just go back to using all glass bottles or paper bags, they actually come in many cases with a bigger carbon footprint, because you have to consider the extra weight of the glass with transport, and paper, obviously cutting down trees and using up a lot of water resource. And it's just, yeah, so plastic's very light. It's also used in a lot of medical equipment, which is very important. So it's difficult to find alternatives when it comes to, you know, having to need sterile equipment in medicine. But yeah, I mean, ultimately we didn't have it before. And another thing with the packaging is that it's keeping our food fresh for a very long time. And so we're saving a lot of food by being able to wrap it in plastic and store it and transport it around the world. But again, as you say, we never used to do this, and we need to try and transition back to not needing a very long shelf life for our food, because we're buying locally and we're buying seasonally. So yeah, I think it's very possible for us to decouple from fossil fuels, especially with so many alternatives that are now becoming available. So I think, yeah, we just need to be investing in these alternatives so that we can decouple from fossil fuels.
Okay, thank you. The next question from the same person, Jayan Pillai. SME exists that convert plastics to oil to be used as an energy source. Are we encouraging them?
Yes, so as I think I mentioned, the EU actually consider burning carbon-based waste as renewable. And unfortunately, plastics currently fall under that category, and so we're eligible for subsidies. And the investments from the petrochemical companies themselves, they don't want to stop producing plastics. They want to continue to produce plastics so they can sell them. And by investing in waste to energy, that is almost finding a loophole around decoupling from fossil fuels. And it sounds renewable, almost the term waste to energy. It sounds like you're doing something good, but it definitely is still burning fossil fuels and having a continual reliance and dependence on a waste stream.
Okay, thank you. Next question. Lots of news on the amount of waste entering the ocean from the use of PPE for COVID. With minds on health, how do you balance with needing to protect ocean?
So again, with masks, I'm seeing, I mean, obviously gloves are a very big problem that people are using with the plastic disposable gloves. You can get silicone gloves, which are a little bit more environmentally friendly, or just use reusable gloves and masks for the general public. That's more than acceptable. For, in the medical industry, it's a little bit different, but generally people don't need to be investing in single-use plastics. We can have reusable masks. We can make up our own bottles of sanitizer. That's what I've been doing, buying a big bottle of alcohol and having a smaller reusable spray that I'm just mixing with alcohol, so I'm not buying lots of bottles of hand sanitizer. So I think it is just about being mindful of what we're using on a day-to-day basis.
Well, our next one is, what can you tell us about some of the recent reports that fungus can eat plastic? Can that help the global problem?
So there have been over, I think, 50 different species of fungus found that can eat various different types of plastic. But this takes weeks to months for them to degrade a very small amount. So I don't think it will ever be scalable enough to deal with the amount we're producing. So I don't think we can escape from the fact we need to reduce and be reusing. But I've heard some researchers speculate that with more investment and developing, fungus at their optimum conditions to tackle various types of plastic, people could maybe quite easily have like a compost heap in their garden where they're putting plastic and growing fungus, potentially edible fungus or food source for something else. So I think it could work on a small scale that is growing, but I don't think it will help the global problem.
Yeah, fine, thank you. We have few minutes in our hand, but we hope to finish the questions. Rolly thanked you. Thank you, Stephanie, for such a broad-ranging and informative talk. Much food for thought. Well, we are thankful to you too, Rolly.
Thank you.
And I have a question to you. Do you propose taxation on production and use of plastics instead of environment-friendly materials like paper, jute, etc.?
No, I would say I'm definitely more of an advocate of alternate materials than I think it needs to be both. I think we need the tax to enforce producers to consider recycled content and changing their design to perhaps a more waste or plant-based alternative. I think that really needs to be a bigger part of the focus. But I think the key thing we're missing is focusing on producer responsibility. And I think it needs to be regulations around producer responsibility that will decouple recyclable material from oil prices.
Okay, who is responsible for the unrecyclable packaging in countries with no recycling infrastructure?
Unfortunately, low and middle income countries have so many problems that they're trying to address. I mean, I've spent quite a lot of time in Indonesia, for example, where, some islands where they're focused on tourism, the plastic problem is a little bit better, but on other islands where they don't have the support of tourism, they don't have businesses, but they have these international companies managing to provide and sell all these single-use sachets, and that's such a big problem there. And because there's so many islands, for example, in Indonesia, it makes having a waste infrastructure from the government very difficult because you've got so many islands, and I mean, Indonesia's capital is sinking, and I think they're more concerned about moving Jakarta than implementing a waste infrastructure at the moment.
Yeah. Thank you. We have 4 more questions. We'll be a little quicker. What is being done to make plastic recycling more accessible?
So there are, as I mentioned, there are a lot of recycling processes that are being new processes that are being developed in Europe, and so we are investing in recycling, but it's about the same investment, I would say. It's very similar rate of investment to waste to energy, which I think we need to be investing more in recycling, because that is at least decreasing our dependency on fossil fuels and keeping things, resources in use as long as possible. But yeah, governments definitely need to be focusing more on recycling in country as opposed to sending it halfway around the world to supposedly be dealt with somewhere else.
Right. Thank you. The next question: evidence from countries such as Kenya, who have banned plastic bags completely, have shown an increase in black markets and smuggling plus alternatives.
I believe that was actually only an initial problem when they implemented the ban. And they found that when they started educating the local community on why they were implementing that ban, the locals understood that it was for the environment, and it became a lot more effective, and the black market started to decrease. And I think that's, you know, generally when it comes to these sorts of environmental regulations, the local community needs to be educated as well. And when that happens, it seems to be very effective.
Thank you. Next question. Alternatives such as polypropylene that are also environmentally damaging. Does this mean alternatives to ban would be more effective?
Alternatives to bans would be more effective.
Alternatives to ban would be more effective.
So alternative, I think we need the bans in order to encourage the alternatives, because you know, the economy isn't going to make these changes itself, because we need the regulations in place to force producers to start investing in alternatives and reducing their dependence on polypropylene, for example. So yeah, I think they're very coupled. We need bans in order to help the alternative companies.
Well, then last one, although it's not a question, it's a comment from Pam. Surely it's technologically possible to create something biodegradable for these tags. Sounds like an engineering, material science, design opportunity to me. Well,
tag.
Comment?
I assume they might mean the acoustic tags that are being, I'm guessing, I think they're mentioning the acoustic tags that are being used to track nets, but I'm assuming that they will be collected when the nets are collected. If you lose a net, or if, like the Ocean Voyage Institute are doing, they're going out having volunteers on yachts that are sailing out in the Pacific, tagging these nets, and then they are all getting collected at a later date by a bigger vessel. I think that's the tags they're referring to, I'm not sure.
Okay then, Stephanie, we are thankful from the IMarEST. I'm quite sure or confident that the audience who were connected, or who are connected now and who will be connected in the future through IMarEST TV, will be benefited out of your presentation, which is very, very timely, and it's very useful too, and it's important to study the ocean literacy. So the audience, those who have participated and those who will be listening to Stephanie, we are equally thankful to you all. Once again, thank you very much, Stephanie.
And thank you very much for hosting, Sajid, and thank you to everybody that's tuned in and who will listen in the future as well. Thank you again to IMarEST. It's been a real pleasure. Thank you.